Good afternoon, everyone. This is Rich Medairos, and we're very happy to provide you with a TACO Tuesday webinar. And today's topic is all about the best software, and it's going to be presented by Mark Chaffee. And I believe Mark is physically in Rhode Island today. And because of the wonderful world of technology, each of us is all over the place. So I think Brett Zerba, who's monitoring in the background, is up in Massachusetts. I, Rich Medairos, am in Florida, and I think Mark is in, Mark, I think you're in Rhode Island, I think.
I am, yes.
Sounds great.
I am sitting in my basement, literally in my basement.
So what we have here is, we're gonna get going here in a couple of seconds. But you'll notice on each of the folks out there and on your control panel, you should have a place where you can under attend. Well, I don't know if it's under attendees, to be honest with you, but you should be able to wave your hand. Click on the wave your hand button to make sure that you can both hear us and see the first page of Mark's screen. We're just going through some housekeeping things here. And the title of Mark's title page is The Best Way to Compare HVAC Systems in the Early Project Design Phase, presented by Mark Chaffee. You should be able to see that, and you should be able to hear me clearly. And if you can, just give us a little hand wave. So it looks like we have multiple hand waves out there. So great, that's terrific. Okay, and we're going to get started in a very short period of time. Just a few other housekeeping things. Brett Zerba and I will be monitoring questions during Mark's presentation. And so we will pick questions as they pop up. And we'll interrupt Mark occasionally when we wind up with a question. And then we'll read the question to Mark, and Mark will say, I know the answer to that, or he'll say, I'll get back to you, or we'll follow up with some other kind of answer. So we try to pick out of the entire audience questions that are somewhat repetitive or common. So we'll do the best we can. And I believe, I'm going to ask Brett this question, I believe that all the questions will eventually be presented to us in some kind of spreadsheet format, and then Brett, you and I and Mark will be able to answer the questions in the future that we don't get to during the live broadcast. Is that correct?
Yes, it is, Rich.
Okay, great. So with that in mind, let me start off by saying thank you very much for attending our webinar this afternoon. And in about 5 seconds, I'm going to turn it over to Mark. And the last thing I want to say before Mark gets started is to be safe out there. So Mark, I'm going to turn it over to you now. And if you could start your presentation, it sounds like we're ready to go.
Hey, Mark, Rich, yes. Just one more thing. This is Brett Zerba. Just a friendly reminder, most of you have sat in on these before. Tomorrow sometime, probably 24 hours after today's webinar is complete, you should get an email. You will get an email from TACO or from the webinar system giving you access to the video that we are taping this, and give you access so you can download your PDH hour credit certificate. So I wanted to make sure we went over that in addition to everything else Rich talked about. So Mark, take it away, my friend.
Great, thank you very much. Thank you all for attending today's presentation. What we are going to do is take a walk through BEST, and BEST is a software tool, and it's actually an acronym, and it stands for the Building Efficiency System Tool. And this was a tool that a number of folks at TACO originally developed many years ago. And about 5 years ago, what we did was we turned it over to the industry. And what I mean the industry, there's a group by the name of the Hydronic Industry Alliance. It's a collection of manufacturers that really span all sorts of equipment, really based around the hydronic industry across all of North America. And collectively, what we've done as an industry group is make Best more powerful, more user-friendly, and put a lot of the features into it that we're going to be talking about today. We also just recently launched a new version, Best 2.2. So we will cover some of the upgrades that we made recently on this side of it. But today, what I'm here to do is to present an energy modeling and budgeting tool. And the budgeting part we'll get into. I think it's very important. And what we're really trying to do is accurately compare HVAC systems. And we're trying to do it very early in the design phase, really before there's a building. So what we want to have happen is we want to have design teams, asset managers, anybody that's involved in building a building, deciding what kind of HVAC system is going to go into that building, what's going to be the use of that building. Are you a school that's building a building that you're going to keep and have for 75, 100 years, or are you building a building that you're going to flip and turn in 2 years because it's an investment? Every building is a little different in terms of the design goals, maybe the type of efficiency level you're going for. Are you going for LEED Platinum? Are you just building a doctor's, two-story doctor's office, right? There are all these decisions that go in. And what we wanted to do is we wanted to provide as much information as possible very early in the design phase so people can go ahead, that design team, that owner, the person that's financing it, the occupant, to make the best decision of what type of system should be going in there, and also the ramifications of some of those choices this year, next year, 30 years from now. So that was kind of the goal of the software, and hopefully you'll see how we're delivering that. But what you can do is it allows for fast, accurate comparison between multiple HVAC systems, and it can do it before there's a building. So this chart that I'm showing here is from ASHRAE 209, which is the Energy Simulation Aided Design for Buildings, ASHRAE Guideline. And what it does is it gets into a lot of detail in defining some of the requirements for providing energy design assistance using different simulations and softwares and everything else. But I really like this chart because it shows the importance of deciding early, right? At the beginning of a project, that lower left quadrant of that green line. So right when a project starts, the choices you make and the level of effort that it takes to make those choices, and better choices and maybe more efficient choices, is very low. But the impact of making those choices is very high. However, where a lot of the typical energy modeling and budgeting tools lie today, your Train Trace, your eQuest, your Energy Plus, that side of it, is further down in the project. And usually the HVAC system is already chosen by that point. It's chosen before a lot of that energy, that hardcore energy modeling is done. Now, let me be very clear. Best is not a replacement for the Energy Plus and the Traces and the other full-blown energy modeling framework. What we're really trying to do is look at HVAC systems, look at budgeting, some costs, some life cycle costs, and just provide a comparison at a very early design stage for that design team to at least have a conversation about, hey, what type of system should we put in here? What should we take a look at? If we're going to take a look at 2 or 3 different systems, how do they compare to each other? And we want to do this back at the beginning. We want to do it almost like where you would be doing, or where ASHRAE 209 says do a box model. But from a box model standpoint, this is like a box model on on steroids with fireworks and all sorts of cool stuff. I mean, we really took it to a whole new level of providing good information on that side of it. So another thing that we did here is that we are introducing a new rating system, or have introduced, and we've been using this for a couple of years now, and continue to refine it as more and more information becomes available, and we can compare actual results to actual buildings going in, and we've upgraded it over time, and we call it beer. Now, in this great stay-at-home COVID cocktail discussion, it's not the beer that probably most of you are thinking of, but just like you have SEERs and IERs, that's an equipment rating, this is a system rating. What we try to do is we look at the building. So it's the energy efficiency rating of the building. And what we can do is we can actually assign a rating, a ratio, so you can compare multiple systems in that side of it. And we have lots of ratings today, but each rating is very specific for that piece of equipment. And it's dependent on the testing condition, the in-lab testing condition, and all of the different pieces of equipment and the different AHRI standards that they're rated to are different, because each manufacturer gets to go ahead and test the equipment to the standard that they make up. So some have different air inlet temperatures, or how the compressor runs, or there's no differentiation between air cooled and water cooled, which can be, you know, as much of a 30% efficiency difference on a piece of equipment. And you have all of these ratings. So how do you go ahead and compare a piece of equipment that you want to put into your HVAC system, and one has an IER, and another has a COP, and another has a AFUE? Well, it might as well look like this. You might as well be comparing apples to oranges to bananas to a head of lettuce. And this is something that has just plagued our industry for a long time, and it's very, very frustrating, because not every IER is created equally, and they can't be compared. So how do you go ahead as a building owner? So you're a building owner and you have to make this huge investment in an HVAC system that you're going to potentially live with for the life of that building. How do you make some of those decisions when it's so tough to compare? Well, what we wanted to really do is introduce this BEER, this building energy efficiency ratio, so you can compare apples to apples on that side of it, and give the power back to somebody to say, yeah, I actually can compare different pieces of equipment, not how they're used and not how they're tested in the lab, but how it's actually applied in a building. And when we get into the best, what I'm going to show is not only in a building, but in your building, in your location, with your parameters. So it's very intuitive, smart, and flexible for the actual building that you're being put in. So what we do is that this is based on real world, not lab. So what we did is we took all of the missing energy consuming components in a system, and we put it into the calculation. So we started, our baseline started with the AHRI test conditions and all the test results, because that's all, you know, public data and everything in there. You can get into all that. And then as an industry, all the manufacturers that were part of this made a lot of this equipment. So we sat down and we said, okay, what's in there? What's not in there? How much more do we have to add in there to bring lab results to an actual system on that side of it? So for instance, IER ratings for cooling on that side of it are based on entering air temperatures of 80 degrees dry bulb. Well, in the real world, no one sets their thermostat to 80 degrees for cooling. I don't want my office, you know, in my building at 80 degrees. Most are set around 72 degrees. So this is just a really kind of quick example of the difference between lab and real world. But that efficiency can be up to about 10% difference in efficiencies just by changing and having that higher entering air temperature. And if you don't correct for that, your calculations in your energy modeling and building modeling are going to be off to begin with. And unless you're a full-time energy modeler and you do this for a living and you're going through all the data and you know how to work all the screens in a train trace or something like that, you can make all those changes, but you really got to know what you're doing. So what we do is we went ahead and we went through all the AHRI standards for all the different pieces of equipment, and we said, okay, what's included? What's not included? And then how does that compare to real world operating conditions? So, let's just take a look at the first line for an air-cooled chiller. Yeah, in the AHRI standard, that 550, 590, the condenser fan, that energy source is included. But the evaporator fan and the chiller water pump are not included. But you got to have that as part of the system to make an entire system work. So we took this side of it, and then we transferred that into a energy source adjustment. And I noticed for some reason here, my calculation just came up as all zeros for energy source included. So although, so on that side of it, we have our first glitch of the day because my automatic adjustment for my Excel file must have gone away when I close my Excel file. So I will fix that up and make sure I'll include this chart along with the final presentation so you can see all the adjustments. But it looks more like your totals at the end. I don't have the all the breakdowns, but certainly for a rooftop unit, we make the changes for entering air conditions. That's about 11%, and the total compensation. So what we did is we said for each of those units, let's make all those adjustments and put it in there. Now you can actually get a building energy efficiency ratio, so you can compare a rooftop unit to a heat pump to a VRF system and have all those numbers, and it's on a consistent scale for that exact building. All right. So that gives you a little bit of the background of what we were trying to achieve. One of the major industry issues that we solved with it, which is being able to compare project to project. And now what I wanted to do is I'll take a quick pause, see if we have any questions at the very beginning. And then what I'm going to do is just hop right into the software and start to give you a little tour to show you how simple and easy this is to use. So Brett, any questions while I take a pause?
Mark, this is Rich. And we did have one question. Actually, we had multiple questions, but one of them is kind of interesting. It says, can this software be used for building retrofits to estimate potential energy savings for applying a certain measure?
A certain measure. You certainly can. I mean, at that point, you know an awful lot about the building. So when I get into the tour, what I'll do is there's one section about some of the preferences where I could change one characteristic of, say, system 1 versus system 2. So I could put in 2 identical systems and then maybe just put in a more efficient pump. Maybe I wanted to go to a variable speed pump that was more efficient, one of these great new DOE compliant pumps that we have. Then I could see the difference between those 2 systems. So I could see, okay, if I went ahead and did an upgrade, what that would be from both a budget and energy cost side. So you can do that in there. So I think that might address it, and I'll give a brief example of that too.
Yeah, Brett, I'm sorry, Mark. I think that was a great answer. That's exactly what they were asking.
Okay. All right. Let's go ahead and get right into that side. So what I've done is I've opened the software. This is what the best tool looks like. Now, as we get a little further down, I'll give you all the details of where you can download this. This is not a web-based program. It is one that you will need to download from the Hydronic Industry Alliance website. So I'll have all the links and everything on there. It's free. So I don't think I mentioned that, but I will mention it again. It's free. So not only is it cool and fast and powerful, it's also free. And so a couple of the later updates, we've had this for about a year. We have this simple building types wizard, and we've added a couple wizards in to this program to really try to make it easier, especially to get started. I will also mention up on the website where you can download this. We have a number of video tutorials that go along with it. So it's getting started, you know, for the medium user. And then, hey, if you're an HVAC system design professional and you really want to get into the nitty gritty, we have some advanced videos at this side of it too. But what I wanted to do, at least today, is kind of give you a little bit of an overview. So the nicest part about this is that this is taking a look at the budget and energy usage and of a project that you are going to build in any particular location on that side of it. So you come in here, and we're just going to give this a little name. So we'll do Taco Tuesday project, and all right, we got our Taco Tuesday project. We're going to choose the country. We have weather data. This is really pulling out weather data, so the climatological side of it for Canada, Mexico, and the United States. We'll stick in the United States. Let's go today down to, how about Pennsylvania? And we'll do Philadelphia, Pennsylvania. So we select, okay, I'm going to be building a building in Philadelphia, and what size building? Just to go ahead and give you an update, you can go ahead, highlight, okay, the length of this building, instead of 100, will be 200 feet. We'll keep it at 100 feet wide, and it will be 5 stories tall. Okay, now what we have is we have a building type. So what we did as a group is we looked at 11 different building types: apartments, casinos, hospitals, medical office, strip malls. And we said, okay, these are a nice selection of different types of buildings, different sizes, different usages on that side of it. And then what we did was we picked the 4 most popular HVAC systems that go into that particular type of building. So in this one, let's pick a hotel on that side of it. So we're going to be building a hotel in Philadelphia, and those are the basic dimensions. And then what I'm going to do is I'm going to hit go. Now, what you have in front of you are the results for that building. And if you look at the bottom, you have 4 different types of systems. So what we're doing is we're looking right down over here, okay? And so these are just ones that we pick that may be typical for a hotel. So we have a fan coil, we have a heat pump, water to air, a PTAC, and a VRF system. And right away, it gives you a nice overview of the annual energy costs. So your annual energy costs, life cycle, first costs, payback, and then an average system life before replacement. And this is just ASHRAE life data right out of their guidelines and recommendations on that side of it. But what's very interesting is if we take a look at that energy usage side of it, you can see where you're using that energy. Look at the first two systems, that red section. That's what we're using for heating on the fossil fuel side of it. Where the next two systems, that's electric, because they're electric-based systems. So you can kind of see the proportion on that side of it and get some good details. So right now, all you've done is said, okay, we're going to build this building in this town, and now I get some basic information. I can take a look at a couple different systems, and we found this very valuable for a design team that's having a discussion very early in the building process that says, hey, what are some of the trade-offs? What should we look at? Wow, we probably should look at a hydronic-based system. Hey, maybe when we're talking to the engineer or designer, let's ask them some questions about that side of it. What could that look like? What might be involved? What are some of the benefits of that side of it? So that is that's kind of your simple building wizard. Get you going, get you some information quickly. You can print it, you can save this, you can email it out, you can do all sorts of stuff on that side of it. But what I want to do is I want to go from here, and I want to hit advanced. Advanced gets you to the main project screen, and this is really kind of the for those of you that might have used this program a couple of years ago, what you used to have to do is kind of get in here and start to enter your information. But now what we've done is all this information is carried over on our project. So we're still in Pennsylvania, Philadelphia. Our building size has come over. Our energy costs have also come over. Now these are automatically updated. So if I go ahead and happen to change from Pennsylvania to Oregon, the costs update from your energy costs, your heat gain, your heat loss, all of that side of it. So it is when we're modeling and looking at a building, it's your building in your location at your costs on that side of it. We're at Philadelphia. All right, so we're back to that side of it. This is all bin data. We can get into a lot of detail as how the bin data is put out, but it is all NOAA weather data that's all plugged in. It's all updated on that side of it. What I would like to do is just is talk about some of the defaults, because what makes this software so easy yet so powerful is that we have gone ahead and we have put in a lot of defaults into the program. But if you want to change something, change it. All we did is use this as a starting point. The more information you know, the better. And as the project gets further and further down line and being built, you know more information. You might know what type of equipment that's being used or the efficiency of a piece of equipment. Then go ahead and put it in. If you have different preferences that you like to work with, put them in. And if you, at any point, if you have any questions about what something means or how it was calculated or the formulas, go to this help file, and on the help file, I'll click on all the methodology, all the calculations are on there. You want to know how to do how the horsepower was calculated, that it wasn't just a rule of thumb, that it's actually based on the horsepower by GPM or CFM for the actual system parameters. Here's how it's calculated. So everything is transparent. We're not trying to hide anything, trick anybody. A lot of times I get the question, oh, you're all hydronic guys. You want to make every hydronic system look like it's going to win. Well, we think a lot of times a hydronic system is definitely the best way to go, but not always. What we just want to do is just to have an equal comparison so somebody can make the choices based on actual information. And if you want to know how the formulas were done or how it was put together, it's completely transparent. So then if you wanted to change something, let's take a look at heat gain, for instance. So I'm going to go over to this heat gain, and I can use the defaults, which is selected now. I get the little radio button on that side of it, but I want to change it. So I'm going to go to user input, and maybe for the heat gain area, instead of 28.9 BTUs a square foot, I want to use 25. So take a look at the number. The heat gain now is about 2.8 million. So if I go to 25, I go ahead and type that in. It's now 2.5 million BTUs per hour on that side of it. So, and then this changes all of the other data that we'll also view later on that side of it. And again, if you know the specific heat gain, I can go ahead and I can enter a breakdown. I can put in, boy, I know what my sensible and laden gain is. I can go ahead and type that in if I know it. Or I can enter just a total. I want to do 3 million BTU. It's completely up to you. Everything in here, almost everything in here is configurable and changeable to meet your preferences, your design, your building, and all of the formulas, the background, everything else is completely visible. We were transparent on that side of it. We wanted you to have complete flexibility on that side of it. I will also note, and I think this gets a little bit to Rich's question before, for the energy costs, right now we have all systems. One of the new features for BESS 2.2 that was just released is I can go ahead and change these parameters or a lot of parameters for each system individually. So say I went, we'll quickly just talk about this. If I go to system 1, so here's all of my data, but I'm just gonna, we're gonna get back here, don't worry. If I go down to preferences, which is all the way down at the bottom here, and I hit that button, the pop-up screen is gonna come. And what I can do is all of the different settings, pressure drops, temperature differentials, electrical costs, I can go ahead and apply them to right over here, right? I can apply them to either every system, or I can choose what system I want to go ahead and apply this to. So here's a good example. I want to model 2 identical HVAC systems. But what I want to do is I want to say, hey, I know my current cost of fossil fuel is $2.44 a gallon. But I'm wondering, hey, boy, what happens if oil, unlike the last couple of weeks, what happens if oil spikes and it goes to $4 a gallon again? What effect is that going to have on my system? So I could simply have system 1 and system 2. I could apply, keep 244 for system 1, and then go ahead for system 2. Go ahead and change that to to $4 on that side of it. And then I can go to my summary screens and see the difference between system 1 and system 2. I could change temperature differentials, types of systems, efficiencies of pumps, fans, AFUE, efficiencies of boiler, et cetera, on that. And then at any point, if I ever want to go back, I can just hit reset to defaults. It will go back to that side of it, and then I can close this window. So that's all in there.
So
I know
Mark,
this is a lot of detail, but it gives you a lot of flexibility. Yes, Rich.
so we have a few questions that popped up. This might be a good point to interject a few questions. So
Absolutely.
if you have a second, let's try the first one is, are these fuel costs based on utility feedback?
Yes, they're national rates. So we go to the U.S. I think it's U.S. DOE database for fuel rates. So it is a summary and a database that you can look up. So they're always current, but they're they're not live by today, but it is the U.S. Averages by location.
And kind of a follow-up question along the same lines is how often is the energy cost updated?
It's updated yearly on that side of it. So what we do is we update. We'll get into it a little later, but we also have a lot of costing information about like first cost and life cycle costs and that side of it. So we update that annually. We both confirm it and then check it to inflation and that side of it. And then the electrical demand, that's a database. So if you go and hit the get rates by state, it links to any updates from that DOE database that's tracking all of the consumption and fuel. But if you know something's different for your particular area, or you're on a better purchase plan for your particular business than an average electrical demand would be for your particular place, just type it in. So if my kilowatts per hour is not, it's 10 cents instead of 12 cents because I buy it differently, just go ahead and type that in and override it so you can get more accurate information for yourself.
I think I know the answer to the next question. I'm going to ask it, and I'll tell you what I think the answer is, and you can confirm. Is this software available as a Mac version instead of in addition to a PC version? I think the answer is no, correct?
It's just a PC version. It's just yeah, at this point it's just downloadable. It's not a web version. We have looked at trying to do a web version. Now the nice thing is with a downloadable version, anytime this lives on your desktop, any changes you make, things you want to save, preferences you want to keep in there, you can change once and it's always in there. Unlike us, who probably does designs for people all across the country, if you're in Philadelphia, Pennsylvania, you're probably doing a lot of projects in that local area, so you can set your defaults to that area, and it's going to stay there. It's also, we don't save the data, we don't track the data because it's on your desktop, but that does it comes with some drawbacks on that side of it, but maybe we'll get to a web version one of these days. But this is where we're at least for now. And
Sounds great.
It's not the Mac. Sorry.
Sounds great, Mark. As the questions pop up, I'll introduce. I'll jump on.
Okay.
Thanks for answering those few questions.
Not a problem. Okay, so what we've done is we've gone through a little bit of the project. We've taken a look at, we've changed some parameters. We looked at the preferences. You can get into a lot of detail very, very, very quickly. Get a lot of good information very quickly, and then you can get really into the weeds if you need to, and bounce back and forth. But what I wanted to do is from this project page, this was our building, our hotel in Philadelphia, PA. But let's take a look. We looked at 4 systems, but let's go ahead and take a look at how those systems compare to each other. So what we can do is up at the top bar, right across the top here that I'm highlighting, is we have the details on the project, and then specifics on each of the systems that were chosen. And you can compare up to 4 systems at any time. You can compare 2 if you want. You don't need to compare all 4, but you can compare up to a max of 4 systems at a time. And then you can always change those at will. And then moving down, we'll have an overview, compare the 4 systems all in one, and then a lot of the costing side of it. So let's first go ahead and take a look at system 1. Now, the way that this is organized is really into thirds as we're moving across. So everything on this first third over here has to do with the generation source. So particular for this system, we're using a boiler. It's a natural gas boiler, 95% efficient. Again, if you want to use a different type of boiler, a different efficiency, just pull down menu, type it in, you're good to go. But this is at least the default system for this air-cooled fan coil system. The center third here is your distribution sources. So how are you moving the water or your air into the system on that side of it. Do you have an economizer? What kind of duct system? All that side of it is defaulted on here. And finally, your terminal equipment. What are your outputs? On this particular one, we have it's a fan coil system. So we have all of the information about the fan coil system. We have the AHRI ratings on here. So if the project gets further down and you're actually have chosen a piece of equipment, you can go ahead and type in that pieces of equipment's IER. What we're doing is we're using averages to at least get you started on that portion of that. So that's kind of how it's laid out. It's generation sources on the left, distribution sources in the middle, terminal equipment on the right-hand side. And then the summary information for that system is up top. So here are your total energy costs. Now this is where BEST really becomes a great tool for taking a look at budgeting on that side of it. How much am I going to spend in electricity, in fossil fuel consumption? What are some of my my system performance metrics on that side of it? And so it provides a lot of cost detail on that portion of it. Another cost detail that we provide is some of the life cycle costs. Both first cost, replacement costs, and a total life cycle cost, which is really important for a lot of asset managers when taking a look at a commercial building. Now, how did we arrive at this cost information? Well, what we did is we went out to 50 major contracting firms across North America and worked with them over a good amount of time to actually price out all of the systems that we're taking a look at. So if I go over here and I click on life cycle, if I go to estimate, I am going to go ahead and pop up this window. And these are all of the systems, so 32 different types of systems that we got actual costs on. So what we wanted to try to do is get as close as possible on that side of it. Now, a building that you build in Oklahoma City is going to be much different in cost than one building in New York City. However, what we found very intriguing was across the country, the difference between two different types of systems was relative, even though the cost might have been different because of the geographic area. So what we have is in this side of it, we have this relative cost. We have a low, medium, and high cost. So if you're in New York City, click on high cost. If you're in Oklahoma City, maybe medium. But if you know if you're a design build contractor and you know some of the cost on the side of it that you charge per square foot, again, you can go ahead and enter that right in. But this gives you at least a starting point of knowing, hey, listen, if I'm comparing very different systems with different equipment efficiencies, at least I can make an apples to apples comparison using the same information from the same people. So again, a very powerful tool, but I at least wanted to introduce where some of that information comes from. Now, if we're talking a look at energy costs on that side of it, this gives you your first breakdown. But if we actually go up to this energy cost tab up at the top here, what we can now do is we can take a look at, hey, how do we compare across all four systems? Where does the fan coil system compare to a VRF system? What is the electrical consumption, the fuel costs? And then if there's a blank spot, that means it's the most cost-effective system. So from a annual energy cost, system one is the least expensive. And then what it will do is it will tell you how much more it is to operate the other systems compared to system one on that side of it. And then what I got into at the beginning was this BEER rating, this building energy efficiency ratio. And this is really taking that equipment rating that's in the lab and translating it to a system rating, a building rating that's actually the way that the performance is going to work in real life under real life conditions. And this is where you're starting to compare apples to apples on the efficiency of a cooling efficiency between the different systems chosen on that side of it. So lots of information to dig in here. From energy costs, you can also break that down if you want more detail. You can go to the next tab, which is monthly energy costs on that side of it. You can look at it from cost data, or you can look at it from consumption side of it. If you have a geothermal, you can do some heat balancing. That's getting into a little more detail than we're looking at. And then you can look at it between the different systems. And compare each of the systems from a cost side of it. So there's lots of details data here. You can download this later, put into an Excel spreadsheet, do some calculations, whatever you'd like to do. All right, again, we've gone down into a lot of detail and gotten into some of the weeds. You can do that pretty quickly. So let's go back up and take a look at some of the other screens. So let's take a look at that overview. So this is probably kind of the nice summary screen that you can get to. So this compares all 4 systems, life cycle, cumulative life cycle cost by year, what that cooling system beer is, the system replacement side of it, and that system replacement certainly goes to your life cycle cost. But the one I wanted to point out, which is really interesting, is this weight of refrigerant. So what we've done is we've actually calculated the weight of refrigerant that's in each of these systems. And this is kind of interesting, especially when you get up into the VRF systems, because I don't think a lot of people understand the amount of refrigerant that is in these systems that's being piped and pumped around a building. And what the differential is between maybe an air conditioning piece of equipment that has a factory sealed compressor that's tested and sealed at the factory that goes into a air conditioning unit that goes out, compared to a system that is open that was going to be piping refrigerant around a system. A very different discussion, probably a whole nother Taco Tuesday for a different day, but very interesting and telling on that side of it when you're talking about safety and dependability and installation and maintenance and that side of it, of just looking at how do you manage that much refrigerant and that side of it. So a nice tab. Continuing to scroll across the top, we took a look at the energy costs, the monthly energy costs, and finally the last screen is that life cycle portion of it. And this is, again, a lot of really good, useful information and data for that design team, that building owner, that asset manager, the person that has to be writing the check of the systems to go, I wonder, given this apples to apples comparison, how much am I going to spend to operate this building, to replace the system? Boy, I'm going to keep this building. I'm planning on keeping this building for 50 years. Boy, I want to flip it. First cost is really interesting to me. So on that side of it, so for instance, if I'm taking a look at, let's take a look at the payback, right? So from a first cost standpoint, system 3 has the least amount of first cost on here. So maybe if I'm building this hotel in Pennsylvania and I'm just looking to, I'm the developer, I'm going to build it and then I'm going to flip it, that may be a lot more important to me. Going, all right, system 1 and 2 and 4 are more expensive, and wow, look at the payback difference here. Wow, this system 4 has a huge payback on this side of it. But if I'm going to own and operate it, maybe I'll come over here to the life cycle cost, and I'll sit here and go, wow, system 1 from a life cycle cost looks to be the best on this side of it, and look how much more I'm going to be spending for the other systems, on an annualized basis to operate this system. So again, every building and every ownership has different goals of what they're trying to achieve, but this can at least start that conversation early in the process on that portion of it. So what we've done is we've looked at the main project page where you're going to first for your data. We've taken a look at the system details of how it's entered, some of the data that comes back, and then the overview tabs on that portion of it. I will also note that if you want, at any point you can go up to File, Print Export, and then what you will get is you'll get a screen, and you can either print them, save them as a PDF, or print them. Or a new feature in the latest release is now you can export them to an Excel file. So say I want it, and then I can check which ones I want. Do I want, maybe I want a System 1 report and then the System Overview report. I can just hit, export to Excel. It goes ahead and starts that process, and it takes a second. If that's why I only did 2 of them to get them into Excel, and then as soon as that is done, I will go ahead and pop those up. So it makes it, the nice part about going to Excel on that side of it is you can go ahead and modify it and change, let's see, I don't need to save that right now. I'll go ahead. And now you have all of your data. So what I did is I downloaded all the data from System 1 and also the overview. And if I wanted to go ahead and, now change the date, change the title, add my logo in, copy this over to another presentation, I can go ahead and do that. So I have complete flexibility over the data that's produced. So that's kind of cool. And if you want to save it, go ahead and save it to your desktop so you have that side of it. The last, well, maybe one of the last ones I want to do is to just talk about data inputting. And so we took a look at just starting with the very basics of choosing a building in that building systems wizard. But what you can do is, so say you go ahead and okay, program starts up. This is the start screen. Instead of entering the data here, what I can do is I can just go to advanced on this side of it. Again, this is now your default screen. It will default to Chicago. If I go over to wizards, I can go to advanced systems. And then what I can do is select by system, and then enter the data in that way. So say for System 1, I want a chilled beam, water cooled is fine, and 2-pipe. And for System 2, maybe I want to do a VRF. How about a geothermal source to air on that side of it? So I want to compare these two systems. I can hit OK. And now what I have is I have all the details of those two systems. The final way to enter data is to go into this system screen and select every drop down for type of source, fuel source, cooling source. Now we're really getting into a lot of detail. What I say is start by selecting that system, have it pop up like this, and then go ahead and change. So say, then I can make change to this. So instead of natural gas, I want an oil boiler that's 85% efficient. I want to, and look at the bar chart at the top when I change this. So say I want water cooled, but it's going to be an air cooled, right? And every time I make a change, I'm going to go from single pipe to a standard 2-pipe. Right? Every time I make a change, it automatically adjusts, the energy adjusts, the graphs adjust what I'm doing. So those are the different ways you can enter information, from just choosing a building to choosing a type of system to selecting every parameter in here for your exact project. Lots of power, but it is certainly to get started. It is certainly easy to get started, and then have lots of power to customize from that point. I think that's a good place for us to go ahead and take another pause, and I'll see if there are any questions before I wrap up.
So Mark, we do have a couple of questions. One is fairly straightforward. The data, I believe, that's in the best software includes the United States, Canada, and Mexico. And the question specifically is, are you folks planning on adding other locations around the globe? And if so, when?
Not right this minute. We could certainly take a look at that. What we have found is that from a bin data standpoint, to add the world takes a lot of computing power and really slows it down and makes it a much bigger file. And that what we found is that somebody outside of the US can usually find a place somewhere in North America that is pretty close climatologically as the location they're in, especially for what you're doing. And remember, this is not your replacement for your full building modeling that you might do later on. This is for your upfront discussion. So, you know, keep your train trace, keep your Energy Plus, keep your big modeling program later on. But what we find is that later on, the design team or the engineer is being paid to do that modeling, and they're not being paid up front. So somebody doesn't want to spend hours, or some of these programs may even take days to enter all the information and get it right. And you don't want to do that when you're not getting paid for it. What you'd rather do is have a quick free tool that gets you some pretty good information to at least have a discussion about options early on.
Sounds great. Another question that popped up actually a couple of times was on the load calculations, the load data. Does the software differentiate sources like the lighting loads or the ventilation loads?
Ventilation is in there, lighting is not. So we're really just comparing HVAC to HVAC system. You can make some changes to differences in modeling exterior versus interior loads. So what is the skin effect, and having a different system on that side of it, you can actually define, okay, for the 12 feet from the outside wall I'm going to model differently than the inside. So there is some power in there. But again, this is really just more as a comparison from HVAC system to HVAC system. If you want to get into all of the other energy inputs and the effects that they have on it, that's really for a much more powerful and probably later on energy modeling software.
Okay, the other question that popped up, and I think I saw you answer this question, Mark, was is the best software limited to a life cycle cost analysis of 20 years?
No. So it's whatever you want to put in there. That's selectable. And the data for the life cycle for the pieces of equipment came out of ASHRAE recommendations for what they consider an average life cycle. And you can change that if you think if the particular piece of equipment or system you're talking about has a life cycle and they're 15 years, but you really think it's going to last 20, put 20 in there. It's all changeable. We just went with ASHRAE guidelines to make it easier on that side of it.
Great. Well, we've answered several of the common questions. Before we proceed, is there anybody else out there that has a question they'd like to ask?
While they're doing that and you put it in, I think it's important. What I want to do is just touch very, very briefly on kind of what BEST is and isn't. And I think some of the questions kind of talk to that a little. So BEST is an early comparison tool. Really kind of before that building is designed, you input as much as you know. It's much better than a box model. It can help tremendously as a budget comparison and discussion tool. It's fast, it's easy, it's much more practical than to run than an Energy Plus, but it's not an Energy Plus. Let BEST be the first step in an overall HVAC system design, not the beginning, the end, and the middle. It's not everything, but it's at least something great to use at the beginning. Also, who should be using it? We think everybody should be using it, but what we wanted to do is we wanted the design team, those people that are responsible for the decisions in that building, to use it, to help them identify choices and options, to have them have the discussion. What is my goal with this building? What do I want it to do? How much am I willing to spend? Is first cost more important than life cycle cost? Is high efficiency more important than I don't care what the efficiency is? And then choosing systems that match up with that. But at the same time, we wanted to make it powerful for that mechanical engineer, that HVAC engineer, to drive multiple scenarios, to get in there and change, heat loss, and instead of a 20-degree temperature differential on a heating zone, to go to 15 and see what it is. And at the end of the day, we wanted the system reports and the details to be able to help everybody communicate better about what the best HVAC system is for that particular building in their location for their design goals. And that's kind of the who and why on that side of it. And then as we go ahead and answer any other questions, I will leave up where you can download the software, which is at HIA-C.org. So it's the Hydronic Industry Alliance-commercial, HIAC.org. And I also pitch some other videos and white papers and presentations and things like that are also up on the site at the same time.
So Mark, that was a great presentation. I think this is a great point at which we can sort of close. And before we do that, is there anything, Mark, that you'd like to add at the end that would be helpful for the audience to hear about?
Boy, I think I covered an awful lot. I hope I gave you a glimpse into some of the ease that, especially if you've worked with any of the energy modeling programs before or budgeting programs before, we went through a lot. We went through it pretty quickly. It's not because I'm an expert in this. It's because it really is simple, fast, accurate, and free. So I want to mention that again, that it is free, and it's really something that a lot of people throughout this entire industry and all sorts of manufacturers have spent a tremendous amount of time working on, improving, and each year we continue to add on to it. So we always welcome feedback. So get in there, use it, and let us know what you think and what else you'd like to see come out of it. And hopefully it will be a very useful tool in your day-to-day business lives out there. So thank you very much for attending. That's really all I have.
Well, Mark, thank you so much for a great presentation. I have to tell you that I have used the software for some projects at Cranston. It doesn't have to be used for a massive building. You can use it for mini projects, and I've used it for several mini projects out at Cranston. So yeah, it's a great tool. I really like using it. So at this point, by the way, Mark, we've had a few people comment, great presentations. I want to pass that along to you. So on behalf of the entire team out here at TACO, we want to express our appreciation for everyone who participated in today's webinar. As I said before, we'll keep track of the questions that were typed in, and we'll send out responses over the next few days to roughly a week. And I think, as Brett indicated earlier, we are recording this session, and in roughly 24 hours, you'll be getting an email that allows you to access the recording. So with that, I'm going to sign off. Before I do that, I want to say again, thanks so much, and please be safe out there. and have a great rest of the week. So take care, everyone, and thanks for participating.